Hello my friends and welcome to the final step of this training implementation. It will be a very easy and fast one because indeed, what if I told you that we can finish the whole training implementation and also launch the training and get the training results in this same tutorial, which won't be too long, you'll see. Well, you already know actually, I don't know yet, but this is my bet. So here we go. Indeed, we have done the biggest and the most difficult part. Now we're just going to do 2 copy-paste and you will see that we will have very few things to change. So here we go. Let's start by initializing our DCQN agent, meaning getting for real our AI. So let's go back to our deep Q-learning implementation. Let's take this line of code. Then let's go back to our deep convolutional Q-learning implementation. Let's create a new code cell. Let's paste that here. And now according to you, what do we have to change here? Well, I'm sure you all know the answer. Of course, we have to remove the state size because now our agent class only expects one argument, which is of course the number of actions. So here we go. We are now ready to finally get our AI. So let's run this cell and let's get our agent. There we go. Now we have an AI for real that not only will be intelligent once we train it, but also has the ability to see images thanks to its eyes represented by the convolutional layers. Alright, and now let's move on to the final step, training the DCQN agent. So let's create a new code cell and now you will see that it's going to be super easy. We're going to once again go back to our deep Q-learning implementation. We're going to take the whole training code here, the training for loop. We're going to go back to our deep convolutional Q-learning implementation. We're going to paste that inside. And now according to you, what do we have to change here? Well, my friends, I have some great news for you. We literally only have to change 2 things. I'm gonna zoom out a bit so that we can see the whole training for loop. There we go. And so as I was saying, we only have 2 things to change. First is the number of time steps per episode, because indeed 1000 won't be enough to give enough training of our agent to play in the Pac-Man environment. So we're gonna increase that to 10,000 time steps. And then, according to you, what is going to be the other parameter value that we have to change here? Because indeed we have nothing else. The whole training for loop is already implemented. We only have to change one final hyperparameter value. And a priori we can't really guess because it requires to already play at least once in the Pac-Man environment. So I'm going to tell you what it is. It has to do with the average score here, that score from which we declare the environment solved. And so actually now that's for us to choose, because indeed in the Pac-Man documentation, unfortunately it doesn't say, like for Lunar Lander, from which value of the score the environment is considered to be solved. Indeed, maybe I missed it, but I don't think so. In the documentation here, we don't see a certain value of the score from which the environment is considered solved. But you have to understand that the reward here in the Pac-Man environment is of course the score that we see in the game. This score here, it starts at 10, but then it increases the more Pac-Man eats some sweets and then doesn't get killed by the monsters. There you go, you see the score here increasing. So that's the score. And so I tried, several trainings and I played a bit with the Pac-Man environment. And well, I think that a good score to consider the environment solved is not 200, but we're going to increase that to 500, because if we reach 500, you will see the agent will be able to eat a good amount of sweets and not get killed too fast by the monsters. So that's the only thing we're going to change here. We're going to replace 200 by 500. And there we go, my friends. The training for loop is now ready. So you see, how efficient was that? We can basically now launch the training and enjoy the results. But now I have to tell you something very important. You understand that now we're no longer training an AI on input vectors, on simple input vectors of small dimension. Now we're training an AI on input images, therefore of a much bigger dimension. And so you can imagine that the training is going to take much more time, and besides it's going to require much more compute resource. And so now we have a choice. Either we don't mind waiting too long for the training and we stay with our tensor processing unit. By the way, let me show you the different resources we have. If you click this little arrow here and then change runtime type, well, you will see the different processing units that you have. So you have the CPU, central processing unit, that's the least powerful. Then you have TPU, tensor processing unit, that's more powerful than CPU. I think it's 3 times more powerful than CPU. Then you have T4 GPU, which is even more powerful than the TPU. That's the best one you would choose among these options that you have in the free tier of Google Colab. However, my suggestion, and of course you don't have to do it, if you want, we can get those more powerful processing units, because indeed after T4 GPU, the more powerful one is A100 GPU, and then the most powerful of all is this one, V100 GPU. So now the choice is yours. Either you don't mind waiting for a few hours to train our AI and you would use the T4 GPU, or we can get access to premium GPUs, it's not that expensive, and get the V100 GPU to train our AI much faster. And as far as I'm concerned, and also for educational purposes, so that we can all enjoy a fast and performant training, well, I'm going to go for the V100 GPU, and to do so, I'm actually going to switch now to my other Google account in which I have indeed a Colab Pro subscription. So I'm going to show you right away. I'm going to cancel this. I'm going to share this notebook just so that I can get a link and then get this Colab notebook in my other Google account with the premium access. So I'm gonna change that to anyone with the link. I'm gonna keep that to viewer. I'm gonna copy the link, and now I'm gonna go back to my other account, my other Google account with Colab Pro, and I'm going to paste that here. So here we go. This is going to take me to my Colab account, but I still have to make a copy of this notebook. So I'm just going to quickly save a copy of this notebook in my drive, but the drive of my other Google account with the Google Pro subscription. And there we go. So let's have a look at what I have. So again, I'm going to click this little arrow here and then change runtime type. And well, okay, I don't have A100 or V100, but that's because even though I'm subscribed to Pro, I consume before all my compute units because I was doing a lot of training and a lot of hyperparameter tuning on this same deep convolutional Q-learning model for Pac-Man. And so I just have to purchase additional compute units, but that's totally fine. I'm happy to do it for educational purposes. And at the same time, you will see the Colab offers. As I told you, it's not that expensive. As you can see, if you want to have now a fast and performant training, well, you just have to pay either 11 euros per month or 11 euros for 100 compute units, and you will get those units to run a performance training. So now I'm in the Colab Pro, but I consume all my compute units. I'm gonna pay as I go, and so I'm gonna go for this. I'm gonna just order now 100 more compute units. I'm gonna agree, and then I'll be able to get the V100. All right, perfect, 11 euros. I'm gonna click buy. And we're now going to enjoy a fast and performant training of our deep convolutional Q-learning model trained on the Pac-Man environment, and we're going to try to reach a score of 500. Alright, it's making the payment, checking out, secure checkout, and sign up successful. Let's go! Alright, so now I should have my compute resource. Okay, so this is okay, we don't need it. And now let's see if I refresh, if I have my V100 GPU, I'm going to refresh this. And let's see if I can switch to the V100 GPU. So I'm going to go back to this little arrow here. By the way, you can also access it here in runtime and then change runtime type. And there we go. I have the V100. This is the most powerful one. And this is the one that will get us a much faster training. All right. And make sure to also select high RAM because, of course, you know, our AI has a memory and that memory is actually provided by the resources of Google Colab. Okay. So let's do this. Let's click save. And now, are you ready? So unfortunately, since it's a copy of the notebook, I just have to run all the cells again. So I'm going to click run all. There we go. It's going to reinstall everything. All right, so now it's installing Gymnasium and great, done. Now it's running the other cells, importing the libraries, creating the architecture, setting up the environment, initializing the hyperparameters, preprocessing the frames, implementing the DCQN class, initializing the DCQN agent, and there we go. The training has started, and of course, even if we have now a powerful GPU, you know, the V100, it's not going to be an as fast training as before, you know, with the dynamic printing. We still have the dynamic printing, but it's going to take much more time. There we go, to get the average score on one episode. So we actually start with an average score of 250 for episode 1, and then it's going to take a few more seconds to get the average score of episode 2. There we go, 255, and then the average score of episode 3, and so on. So let's hope that we will get that, you know, threshold of average score, you know, the average score of a 100 episode over 500, in which case, well, we consider to have solved the environment and we consider to have a performant agent able to play Pac-Man. So episode 4, we have reached 257. So it's a good start. It seems to be increasing a bit already. but what we're interested in, of course, is the average score on 100 episodes. 258 for episode 5. So there we go. So now it is training. Of course, I'm not gonna comment the average score on all the episodes, even if I would love to do so, because it's gonna still take quite much time. 256 on episode 6. Okay, good. But as I was saying, it's gonna take a lot of time, so I'm just gonna fast forward here video, and I'll see you if, of course, we reach an average score on 100 episodes of over 500, in which case, the training will break and we will have that final note, environment solved in a certain number of episodes with the average score being over 500. So let's hope we get that, and I guess I'll meet you if and once we reach that score. .494 at episode 729. I feel that we're super close. I think we're gonna touch soon the 500, our threshold for considering the environment solved. We had a very good and steady increase of the average score over the hundreds of episodes, and sometimes the average score would decrease a bit in order for the agent to do a bit of exploration. But now it seems to have found a good action subspace. Oh, there you go. Average score of 499.70. We're super close. We're super close to our 500 threshold. I think it's imminent now. We are at episode 732. 497, still doing a bit more of exploration, but it's so close. It's so close. I've been waiting for, actually the training was 2 hours, and I've been waiting in front of my laptop to see how the average score evolves, and I can say that I'm pretty happy at the evolution. We had a steady increase, 306, 323, 394, and there we go! 633 episodes for the environment to get solved, and we reach an average score of 508.60. Congratulations, my friends. Please share in the comments what you got, in how many episodes you reached that average score of 508. But there you go, that was a beautiful training. We had a steady increase of the average score while having at the same time a bit of exploration. Indeed, from episode 500 to 600, we decreased the average score by quite a bit. But that was just in order for the agent to do a bit of exploration, in order to, explore some different action subspaces to maybe find a subspace of actions that could potentially lead to a higher average score. And probably that's what happened, because then from 600 to 700, it considerably improved the average score from 393 to 467, after which probably it found a good direction of actions leading to increase the average score, and that's what we obtained at the end with an average score of 508.60 reached at episode 733. But since we consider the lower bound of scoring window, well, the environment was solved in 633 episodes. Again, please share in the comments what you got. I'm super curious, and congratulations for having solved the environment. Alright, so let's stop here for this tutorial. Let's take a little break, and in the next one we will enjoy the final result, visualizing our agent playing the game of Pac-Man with a good coffee or tea. I can't wait to see you in that next tutorial, and until then, enjoy AI. Hello my friends, and welcome to part 3 of this implementation, visualizing the results. We have just finished a beautiful training of our AI, the deep convolutional Q-learning model for Pac-Man. We ended up with this nice score of 508.60, which is above indeed our threshold for considering the environment solved. And now we can just sit back with a good coffee or a good tea or orange juice, whatever you prefer, and enjoy the final results. Because indeed, now it's exactly the same. The code to visualize the results is exactly the same as before in our deep Q-learning implementation. Of course, the only thing that changes is the name of the environment, Miss Pac-Man Deterministic V0. Alright, and that's it. All the rest is the same. We have the same show video function, and then we call it to show the final video. So what I suggest we do here super quickly is that we don't look at it. We're going to enjoy the results in the full screen video. So I'm going to download it immediately. I'm going to download it to my desktop. Here we go. It is downloading. There we go, the desktop. I'm going to save it. And I'm going to go immediately to my desktop to watch the video with you of the final results. So I'm going to put it in full screen. Sorry for the low resolution, but we'll be able to see well enough. So my friends, are you ready to visualize our AI now playing a game with its own eyes just like a human being and trying to achieve the highest scores possible? So let's just expect what we're going to get here. Remember that we trained our AI to try to reach a score of above 500. So probably here we're going to get a score around 500. Of course, if we had trained the AI longer, maybe we would get a higher score, but it's possible that we get a high score or even a lower score. We don't know. But since we trained the AI to get an average score over 500 over 100 episodes, well, probably we'll get a good score here. Okay, so are you ready? Remember that our AI is now not only intelligent at playing Pac-Man, but also is able to see the game of Pac-Man while it's playing. So that's amazing, right? That's as if we get closer and closer to building a real artificial intelligence mimicking human intelligence. All right, just wanted you to be aware of that when I press play. So here we go. 3, 2, 1, go. And here is the game of Pac-Man starting, and there we go. It's hitting some sweets pretty well. It's hitting some sweets, trying to avoid the monsters. Ah, it got caught. Okay, so second round, it's hitting more sweets, more sweets. Yeah, very good, very good, very good. No, turn right, turn right, turn right. What is it doing? Okay, good, 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 good. Now it's going back up. Good, excellent, excellent. It's hitting a lot of sweets. As you can see, the score is really good. 700. Did you see that? And the score is going to increase now probably because it's going to eat more sweets. Miss Pac-Man is doing really, really good. 790, and that's the end of the episode. Wow, that was a great one. Miss Pac-Man did really amazing here. And remember that it was playing with its own eyes, with the convolutional layers, getting all these frames that we just saw as input and then processing them and then sending them to the neural network and then using deep Q-learning to play great actions in order to catch the maximum sweets and get the maximum score. So that was a beautiful one. I'm going to save the video for you. I'm going to share it in the lecture so that you can watch it, but you're probably going to get another video that is just as good, or maybe you'll get an even higher score here with the inference mode. If that's the case, please share, or even if you did some more hyperparameter tuning during the training and you got an even better average score, well, please share in the comments. And also, if you got a lower score than the one we just got here, that's totally normal. It can happen that during the inference mode, the AI doesn't do as well as what we just saw, but here it really did very well. Alright, so that marks the end of this part 2 on deep convolutional Q-learning. We're still gonna end this section with a little tutorial with ChatGPT just to see what ChatGPT suggests to us when trying to solve the Pac-Man environment with a deep convolutional Q-learning model. So it will be a quick tutorial just like the one we did in deep Q-learning section. I look forward to seeing you there, and until then, enjoy AI. Hello my friends, alright, so let's finish this deep convolutional Q-learning part 2 with a little ChatGPT tutorial just to check if we got the best architecture or if ChatGPT can provide us some ideas of how to improve the neural network we built. We never know, even though it seemed that we already got some good training results. Alright, so right now I'm in my ChatGPT Plus account, so I'm gonna select GPT-4 and then the default option selected. So here we go, I'm gonna say, hey ChatGPT, can you please implement a deep convolutional Q-learning model for Miss... Actually, let's get the exact name of the environment. Reconnect, yes, okay. For, here we go, Miss Pac-Man Deterministic V0. So I'm copying it here. I'm gonna paste that exactly here. And there we go. For Miss Pac-Man deterministic V0 in PyTorch, very important. I remind that PyTorch is much better than TensorFlow for deep reinforcement learning. So in PyTorch, and voila. We're just going to stop here because we mostly want to see if it returns a different kind of architecture than the one we built. All the rest of our code works perfectly well, so we're mainly interested in the architecture. So here we go. Hey ChatGPT, can you please implement a deep convolutional Q-learning model for Miss Pac-Man deterministic V0 in PyTorch? Here we go. Pressed enter. Certainly, deep learning with convolutional neural network is a powerful combination for training agents. Setup. Okay, so we have the pip install, all the imports. Great. First, it creates the DQN class with... It seems to be a different architecture. Okay, we'll have a look again at it. And okay, so it implements the replay buffer class. We chose to integrate directly in the training for loop, but that's all right. And then it defines the train function for the main training loop. Okay, does it implement epsilon greedy? Probably. We'll have a look at it again. And what does it do also? It goes too fast. Preprocess. See, it builds also the preprocess function. And okay, so done. We'll have a look at it again. But there we go. What I mainly wanted to see is the architecture and compare it to ours. So let's have a look at the neural network at the top. Here we go. So create the DQN. Okay. So it starts with a convolutional layer of 32 filters with a kernel size of 8 and a stride of 4. Just like what we did, the kernel size and the stride are reducing over the different convolutions. And the feature maps are increasing. The filters are increasing. So that's pretty similar to what we did. We went up to 128 here. It chose to stop at 64. We could try this architecture as well. But anyway, I think it will lead us to very, very similar results. And then for the full connection, the fully connected layer, well, it also chose 512 artificial neurons here. So pretty similar. And then it made the forward method, okay, resizing the tensor for the flattening, okay, feature size. So it chose to implement separately experience replay. That's totally fine. We could have done the same thing actually. And then the main training for loop. Here it does exactly the same. It's pre-processing the state input images, unsqueezing them to add this extra dimension of the batch and sending to the proper device. Then here that's where it integrates experience replay by adding experiences to the memory. And then here that's where it gets separately the states, action, rewards, next states, and dons, and converting all that into torch tensors. Then it applies deep Q-learning with the Q values, the next Q targets, and the targets. And then it computes the loss between the expected Q values and the targets. Then it uses the optimizer, first resetting it and then back propagating the loss and then using the optimizer to update the model's parameters. Then we have the preprocess function to preprocess the images, the input states, and then the main function. Okay, so anyway, what I was mostly interested in is this architecture that was suggested here by ChatGPT. Feel free to try it if you want. I'm pretty sure it won't really improve the results and at best get some very similar results. So there you go, your choice. It's always very good if you can practice a bit more, if you can do a little bit more of hyperparameter tuning. And of course, please share in the comments or the Q&A if you manage to get some much better training results and a much higher score at the end in the inference mode. And please, if you can, share the video if you get a really great one. So now it is time for me to say huge congratulations for having implemented the deep convolutional Q-learning model and having got those beautiful results at the end. Now I look forward to seeing you in part 3, where we will implement an even more powerful AI model, which is the A3C model. And just to give you a teaser of what will be improved in terms of artificial intelligence, well, in part 1 with the deep Q-learning model, we built an artificial brain containing only artificial neurons. Then in part 2 with deep convolutional Q-learning, we built not only a brain with artificial neurons, but also some artificial eyes. And now, according to you, what will be this extra feature that will get our artificial intelligence closer to human intelligence? Well, I'm going to tell you right now that is going to be a critic sense. Indeed, that's exactly what we're going to bring to our AI. Besides the brain and the eyes that we were already able to build, we're going to also bring to our AI a critic sense. And that's exactly what the A3C model is about. So I can't wait to see you in part 3 to implement it with you. And until then, enjoy AI.